Good morning, ladies and gentlemen. We've got two honors. We've really finished up what we're going to cover in chapter 13. That being the case, we're going to do some review. Now, we didn't do the entire chapter 13. And so So the main thing we did is exponential growth functions and exponential decay functions. And then the sections 13.2 and 13.3. So we have a study guide here that we're going to take today with. We should be able to get through all of this today. So we'll see how it goes. So we're just going to have a class discussion on this. So we go to problem 1. You have a car decreasing in value at a rate of 15% each year. Write an exponential decay function based on the situation. Then use your function to determine when the value of the car will be $4,000 to the nearest year. So, and the idea is that you can wait. So I hear some of you talking about this and trying to work through this. That's good. We'll just wait a minute. Yes, this would be a calculator problem. Problems like this, we solve them in our calculator mostly by doing what?
Plugging in.
Graphing. Graphing, right?
Right.
Now this could be solved as a exponential equation using a logarithm too, but we are going to work on logarithms starting next week a little bit, so that'll be good. Okay. What do you think on this one?
I think it's 5 years. I think it is 5 years.
I think it's 5 years. Let's not put the cart before the horse. That means let's go ahead and get our function first, right?
It's 10 years.
10?
Yeah.
Like Chloe's really good. She's just sitting there, all smug and smiley. I know what that. I know what. Taking pride in
She didn't
her.
practice one.
So if you put your windows up like that earlier, you would have lied it out. You already have to go through that about it.
All right, Chloe. You just had the smug look on your face. So you go. We got to hear it from you.
Oh, for me?
From you, yes, because you're just so good right there.
That's what happens in your
And the max is 5,000.
yeah, I guess. I said 4,000 equals 20,300, and then the little parentheses 1 minus 0.13 means the power of t.
So this is the equation you use, right?
Yes.
Before we go on and solve this, I want to mention something because I talked about not putting the cart before the horse.
That was
So let's.
the apple.
So what I want to do is this. I want to do this step first. So it's going to be. I'm just looking at a of t equals p sub 0, or actually they said use this thing right here. So 20,300 times 0.85 to the power of t. Okay, see, so that would be your equation, right?
Yep.
That would be, okay, go ahead. take over.
And then I plugged it into my calculator, and so I said like, y equals 20,300, blah, blah, blah. And then I said y also equals 4,000, so I'm over the intercept.
Good job, Chloe.
Thanks.
Okay, and I'm gonna, because what Chloe told me, I'm gonna cheat on this a little bit. I'll tell you what cheating I'm gonna do. Oops, that's the wrong kind of equation. That's pre-calculus right now. Let's get to the regular. Yeah, T, that's, what this is called a parametric equation. You guys in pre-calculus next year, you will do that. Yeah, it is cool. This calculator we have does so many things. Okay, clear. Okay, clear. So we have 2,300 times 0.85. I'm not hearing a phone going off, am I?
No.
Right by you.
I
Right behind
actually
you, Mr. G.
did. I actually did.
Okay, would you make one?
So anyway,
I hear it was that.
window,
Play your hot boy.
I'm gonna go from 0 to 15, and that's the cheating I'm doing. I know we need that many years. Okay, and then we're gonna start at, I'm gonna go from 0 to 20, I'll go about 22,000. Oops, 22,000 by thousands. So graph, so you have something like this.
Yes, second trace and
What?
Okay, good. So how many years?
10.
10.
Years.
She was
Okay,
ready.
she was right. All right.
Is there an earthquake?
Okay, really good. Good job.
Is there an earthquake?
I think so.
Okay,
What's that noise?
Oh, I did it.
we have in this classroom students that are trying to annoy see what they can get away with in annoying their teacher.
I don't think that's what's
No, it's pretty cool to look.
So 10 years,
And then you do it.
so about 10 years.
Like, I think a lot of noise, dude.
By the way, yesterday's class was really good. I appreciate that because I had to be gone 7th and 8th periods tomorrow. Had to do some emergency dental work.
How was that?
But the class was good. The class was good because what happens is they played the video on 7th and 8th period. I'm going to hear about that
I
today.
wasn't gonna do it.
So that worked. That helped.
Okay.
I should be on my
So it's Marcus doing.
No,
Trying to,
I started doing it because he was doing it. It's pretty cool. Look, Mr. G.
I'm one of my cycles.
oh, vibration. Okay. I see what you're saying because we can make mathematics out of that, right? That's what you're saying. Yeah.
1, 5, 6, 7.
Has a frequency.
It's that lesson.
Has hertz,
Watch
right?
one, watch one.
Okay, so it's a all right, yeah, so I don't know how many, we could look at cycles per second.
What's that?
Okay, what happens, will the transformation of f of x equals b of the x change the function's end behavior when the function is translated horizontally?
No.
It will not, no. What about reflected across the x-axis?
Yes.
Yes. So let's go ahead and talk about this because there's going to be a question on the test that kind of gives you this, but it's going to ask a whole bunch of different things, even more than these two. And so you just have to look at it. So if you take the function here, and you can just put any version here, b to the x. Yeah, so we're going to go ahead, I'm going to make this an exponential decay function. So if we translate, so we see what the end behavior is, right? As x approaches infinity, f of x approaches 0. As f of x approaches negative infinity, f of x approaches infinity. And so if you translate this thing horizontally, you see that end behavior is not changing at all.
Right.
But if you reflect across the x-axis, we're going to do that right here.
Oh.
If you reflect across the x-axis, is that going to change the end behavior?
Yeah.
Yeah, this end behavior at the right will not change, but look at the end behavior at the left. Will change. All right? Okay, thank you. That was some good analysis there. Next, for h of x equals -1/3
Good job.
times 4 to the power of x plus 2 plus 3, what are the domain and range of the function? Okay, domain, I'm going to write it two different ways here. I'm going to write it in set notation and in interval notation. So domain is going to be of this.
X such that X.
That would have been
All
an
real numbers.
Yeah, okay, so Braden had it. Braden has us covered. Okay, and then in interval notation, you'd write it like this, right? Okay, range. What's the most important number to look at for range?
3. Okay.
Yeah, k equals 3, thank you. Siggy and Braden, thank you, gentlemen.
Love you, Brady.
So we have
So,
y such that y is what?
That's okay.
What? Y is
Less
what?
than 30.
Less than 3. How'd you get less than 3?
Because it's a
Negative
negative
1/3, right? Thank you. And then in interval notation, it's going to be
Negative infinity. 30.
negative infinity 3. So I know when Braden gets that test next week, he's going to look at that and say, "Man, this is just embarrassingly
he's
easy."
like, I'm wasting my time doing
Yeah.
Right.
this.
Maybe I should have taken it.
It should take. It's too easy for me to take. Okay, questions on that one? Okay. Now on your test.
Next problem is a calculator.
Yeah.
I think so.
Wow.
Okay, reference points. Talk about reference points. Graph the function, this function, labeling the new values of the reference points in the asymptote. So what's going to be our parent function for this?
4x.
4 to the power of x. So for this, which reference points are we going to use?
Negative 1, 0.
0,
Or
1.
0, 1.
0,
Yes.
0, 1. Yeah, 0, 1. Got to watch out, okay? Is this going to be a b greater than 1? Yeah, so we got to use 0, 1. And so if we plug in for this, what are we going to get? If we plug in 0, what do we get?
1.
1.
1. If we plug in 1, what do we get?
4.
4. So those will be our reference points.
Right.
Okay.
Okay.
So now we're going to go ahead and take these reference points and move them along. So I'm going to start over here to the left. I'm going to try to get a skinny pen to leave myself more room. So we have 0, 1. And I forgot something I wanted to do first though. 1, 4. I wanted to take note of horizontal asymptote, right? So y is equal to 3. Okay, so now we go here and we say, what do you want to do first? Reflect.
Plus, yeah, we'll do that first.
Reflect x-axis, right? So we reflect across the x-axis. What do we have here?
0,
Yeah, 0,
-1.
-1. And 1, -4. Okay, great. What's the next thing to do?
Up 3.
Up 3. Well, we didn't have to do it in this order, but since Braden said to do it in this order, we're going to go along with Braden. Up 3. I'm just going to put up 3 here. So if we go up 3, what is that going to do to it? 0, 2, and 0, -1. 1, thank you. Thank you for that. 1, -1, thank you. And then next thing,
That's 2.
left 2, okay, left 2.
Wow. Left
So if we go left 2, what do we get here?
2. Negative 2, 2,
Negative 2, 2,
and 3, negative 1.
and 3,
No. Negative 1, negative 1.
negative 1.
Oh, yeah. I went right, my bad.
Yeah, that's right, that's good, I'm glad you do it, because you're kind of talking through it, so that's good. So I appreciate Marcus and Natalie and everybody else who's engaged in this. It's really engaged. So anyway, we're going to go ahead and mark these points here. So we get negative 2, 2. And we get negative 1, negative 1, like this, right? Now, what was, oh, I forgot what I was going to say. That happens. Okay, so now we're gonna do what next?
Straight. Or press.
Press.
Yeah, we're gonna compress, and I've sort of ran out of room here. So we're gonna compress,
1/3.
and it's be vertical compression by a factor of 1/3, right?
Right.
Yes.
And I made this problem up, and so I have sort of the fractions are going to sort of make things, complicate things a little bit. But we know that our input values are the same, so I'm going to put negative 2 here, and we have something here, and we're going to put negative 1 here. And so our factor is 1/3, so what do we have to do here? Yeah, we have to come up closer to this horizontal asymptote. And so it's like, and so this distance here is 1, has to be 1/3. So we're going to get is 3 minus 1/3. Does that make sense?
Okay.
So what that's going to be, it's going to be like 2 2/3. Wrote it as a mixed number. So that's going to go right here. Yeah, 1/3 of the distance, right? Now this one here, how far is this one away? 4, right?
1 and 1/3 away.
Yeah, so what happens is Marcus, I think, hit it. So if you take 4 and divide that by 3, you get 4/3, right? So you're going to be 4/3 away. So it's going to be 1 and 1/3 away here. So this is kind of complicated. So this is going to be 1 and 2/3, right? And so the thing's going to look something like this. And I think the one you have on your test is going to have numbers that are a little easier to work with than that. But it'll look like that, right? Okay?
All right.
All right, so it's not asking us for domain and range, so we should just move on from here, right?
Yes.
Okay. Okay, here we have next problem, lab sample. And Petri dish starts out with 200 cells. The cells increase in this number by a rate of 21% per day. Find the function that models this situation. Then predict how long it will take the population of cells to quadruple in number. Round your answer to the nearest tenth of a day.
Mr. G,
I don't know, I think that came from up here.
I'm pretty sure that was closer.
My phone's really right here.
I saw where it came from.
It's literally every day.
Marty, why don't you just turn in your phone?
People are just coming in here. And I'm not talking about the whole class. Just maybe a couple people. What am I going to do to kind of push the buttons to try to annoy the teacher? That's what this is.
Or he's just kidding.
And maybe you're being a little bit successful at it. That happens, I get it. I'm not the first. You're going to try to annoy, nor will I be the last. Okay. All right, what do you think? Somebody besides Chloe?
I'm doing it.
Chloe's just smart.
We're almost done.
Sorry.
Because I know Chloe already figured it out. Didn't you, Chloe?
Yeah.
Yeah, she did. Yeah, I admit it. You cannot see on camera, but Chloe is just sitting there, just so smug. Like,
Spin the camera.
I embarrassed the poor girl.
I did X max 50, Y max 1,000.
Okay, can somebody provide us with a function that models the situation? What is the function that models the situation?
I got the 18.
What is your function that models the situation? You have to let me say it? Do I have to say it?
800.
Wait,
Go
the
ahead.
function,
A-
yeah,
FT,
equals P sub O,
P sub O. In this case, they gave us P sub O, right? So we're going to start.
200. 1 plus 0.21.
1.21.
Plus 0.21
And then repeat.
to the power of T. Okay, good. All right, Atlee, and I know others were on the ball here too. Good job. All right, and so now we can use this function, right?
Yes.
So how would we do that?
800 equals 200.
1.21.
To the power of T, okay.
The answer.
So we can go to our calculator. So clear. So I'll put 800 here and 200 times 1 point. Now, Chloe, I do want to ask you something here. I heard you talking about the window settings. What window settings did you choose and how did you decide to do that?
Yeah, how did you choose?
How did I choose them?
A window.
I knew X is always going to be like T, so like it says like nearest 10th of the day, so I didn't think it'd go too far, so I just picked 50 to be safe.
50?
Yep, and then
Okay.
Y, it says that it starts at 200 and it will be 800, so I just picked 1,000.
Okay.
Okay.
Okay, so really, I want you to get, I want her to explain it. I think she explained it quite well. So she talked about her thought process in setting a window, right? And to me, it's not the most crucial thing in the world because even if you don't go through that thought process, you're going to be able to change pretty easily, right? So there's not a penalty for getting your window wrong, but what happens is I, as an experienced mathematician, like I sort of think through that the way she does. I wanted her to explain it. She did a great job, frankly. You know.
Yeah.
So here, and then so what is our answer here?
7.3.
So 7.27 is approximately 7.3 days, right? Okay, good work. Questions on that one?
No.
Okay. All right, good job. Okay, here we have this one. Compare the graph of fx equals 1/2 power of x. What are the graphic transformations of fx produce? G of x equals 2/3 the power of 1/2 to the power of x plus 2 minus 4. What are our graphical transformations? We'll say g of x is f of x, what?
Translated left,
Translated
2 units to the left.
left, oops, 2 units,
Yeah,
Down 4.
and down 4.
and we'll just say and down 4 units. Anything else?
Stretch.
Compressed.
Compressed.
Still my birthday.
Also, we'll say also
What?
f of x
Say your birthday?
is
Compressed by a factor of,
vertically compressed
by a factor of
So I heard somebody say compressed by factor of 3
2/3.
by a factor of 2/3, that's right. Of 2/3. And can you see, is there any reflection involved here about the x-axis? No, there's not. Okay, so really that's it, right?
Yeah.
But when you get a problem like this, make sure you watch for that reflection possibility too, right? If that happens to be negative, right? That would be another possibility.
Yep.
Okay, all right, let's go ahead. Write the function represented by graph and state the domain and range using set notation. What I'm going to do here is I'm going to move my graphic over here to leave more work room on the left side. Yeah, I'm looking for, I'm seeing a left hand going to work out here.
Yeah, a little weirdo. A little weird.
And I see people, I see people looking up and thinking about it too.
How many left hands
Is that
do
an
you
important
see
phase? Is looking at it and thinking about it an important phase of solving a problem? Yeah, it is.
That is very cool.
I can't write with my left hand.
Everybody wants to be cool.
I do it every day.
That's true, I guess.
I think my handwriting's better with my left hand than my right.
Can you tell them to stop
For
blaming
different
me?
things.
Oh my
Pardon
gosh,
me?
so
They're blaming me for the phone, and can you tell them to stop?
It's gonna make Adam cry.
Okay, stop.
Mr. G, look. See, that's my left hand. You feel good?
Yeah, looks
Pretty good, right? Better than
Look, dude. Look.
It's
Hey,
off.
now turn it back on.
That's
That's why you have notifications on your phone.
Okay, but I think.
But it's off. The ring is off.
All right, better.
Okay, well, let's
Here, let's check it out.
please. All right, so this one right here, I'm gonna say domain,
At least, no, what's your phone?
I'm a domain, I'll write first.
Everywhere.
She has hers turned on. No, she doesn't.
Why is that already?
Okay, in range,
My dad.
I'm gonna say y such that y is, looks like gonna be greater than 1. So I got those out of the way. So for the reference points for this kind of thing, we're going to use, to have standard reference points, we're going to have -1 something and 0, 1. So we have x, f of x, right? So we don't know what this thing is yet, but we know this one here. So which point is this one relative to? This one here.
I think it's
-1, or that one's 0, 1.
So
Oh.
So this is the 0, 1 translated, right? This is 0, 1 translated. And so this should help us find out what h and k are, right?
Yep.
So for this one, h is going to be equal to what?
Negative
2 to the left,
Plus 2.
2 to the left, so h is negative 2. All right, and k is going to be, right?
It's gonna be 2, 1/3.
2/3.
It's going to be,
1 2/3.
1,
1 2/3.
3.
No. It's 2/3.
It's gonna be 2.
Oh, yeah,
that's wrong somehow.
Wrong?
Everything's wrong.
But k is going to be 1, because that's where the asymptote is, right?
Oh, yeah.
K is 1.
Yeah.
What made that do that?
K is 1, so that's what that is.
K equals 1.
That's right.
So you got to look for what the horizontal asymptote for the value of k. I was looking at it for a while, trying to think. But that's what k is. K is equal to 1, right?
Okay. So it's 2/3?
So anyway, now we're able to start here. We can write f of x equals, we're going to have a times b to the power of
T.
X plus 2.
x plus 2, and then we have
Plus T.
plus 1. And so now we can take this point in here, can't we?
Yeah.
So we're going to put 5/3 equals a times b to the power of
Negative 2.
-2 plus 2, and then plus 1. And so what's -2 plus 2?
Equals
0.
0, right? So what it is that's going to be 1 now, right? So we have as 5/3 is going to be equal to a
1.
plus 1. And 1, I know, happens to be 3/3.
Yeah.
And now if we solve for a, what do we do here to solve for a?
It's gonna be 8/3.
Subtract 3/3, so a is equal to what? 2/3. Okay? So now, what we have here, I'm going to continue to work to the right. We'll have f of x equals 2/3 b to the power of x plus 2, and then plus 1 here. What next?
Plug in the other one.
Plug in the point.
Plug in this point here, so we have 3 equals 2/3 b to the power of, well, we're given x, right? -3 plus 2, and then plus 1 out here. What's -3 plus 1? Yeah, it's going to be -1. So we have 3 equals 2/3 b to the -1 plus 1. What next? So we subtract 1 here. So we get, everybody see that, subtract 1? So we get 2 equals 2/3. And what happens to this b to the -1 power? It goes to the bottom, yes. So what we have is this. I'm going to put this over 1. So what's b going to be? Well, these will cancel out, right? Divide by that.
1/3.
B is gonna come up here, so B is gonna be
1/3.
1/3, right? Yeah, because if you cross multiply the B, you get B is equal to 1/3. So B is equal to 1/3. So what are we left with? We are left with f of x equals 2/3. Then we have 1/3 to the power of x plus 2 plus 1. And the last thing you can do is check in your calculator to make sure that's right. Anybody check it yet? Okay,
That's right.
we're just about out of class time. But given an exponential function, find the average rate of change. Well, average rate of change, we haven't done one of these. Average rate of change equals f of b minus f of a over b minus a. And so what we have is b is equal to 6, a is equal to 0. So what we have is we plug in for 6, so it's going to be f of 6 minus f of 0 over 6 minus 0. And so you plug in for 6, get a number. You plug in for 0. Well, if we plug in 0, we're going to get 3. I know we're going to get 3, right? Because that's going to be 0. So that's how you would do that one. And then you get a number. And I think it's going to be a negative rate of change, because you got a decreasing, so you get a negative number.
Yep.
And then this one here, I didn't get a chance. This is an E thing. So what I'm going to do is I'm going to try to talk Monday about, kind of finish 8 and maybe work 9. We'll probably have a test on Tuesday.
Okay.
And Monday we're going to start on logarithms too, so that's probably where we are. All right, thank you, class. Good participation from most of you today. That's been good. Chloe, Braden, Atlee, Marcus, others.